In this exercise, we'll maximize area. We're told that a computer parts company wants to make a rectangular memory board that has a perimeter of 28 centimeters. We're asked what dimensions will allow the board to have a maximum area. We'll familiarize ourselves with the problem by letting L represent the length of the board and W represent the width of the board. Both of these be in centimeters. We're dealing with perimeter and area, so let's recall the formula for the perimeter of a rectangle. That's 2 times the length plus 2 times the width. And the formula for area is length times width. In the translate step, we want to write the area using only one variable, not length times width. So we'll go to step 2, translate. And we know something about the perimeter of the memory board. It's 28 centimeters. So we can say that 28 is 2 times the length plus 2 times the width. And let's go ahead and solve for the length so that we can substitute in the area and just have area with just width as the only variable. Subtracting 2 from both sides, we have 2 times the length is 28 minus 2w. And dividing everything by 2, we have that the length is 14 minus w. Now, if the area is the length times the width, but the length is 14 minus the width, I can substitute, and I have area is 14 minus the width minus w times w. Or 14w minus w squared, or since we typically put these in descending order, the opposite of w squared plus 14w, and that equals the area. Now what I've worked through here is I've used what I know about the perimeter to solve for L in terms of w, to substitute to get an expression for the area with only one variable. That was the key through the translate step. The third step, instead of titling it solve, we're going to call it the carry out step, because instead of solving an equation, we're going to try to find a maximum value. This is a quadratic function. Its graph is going to be a parabola, and because it's a negative coefficient, it will open down. So if we can find the vertex, we'll be able to find the maximum value that this parabola has, or that this quadratic expression has. So we're going to complete the square in order to find the vertex. We have the area equals, and I'm going to factor out a -1. So inside parentheses, I will have w squared minus 14w. Now, I need to leave a by itself. So the number that I want to add to complete the square is half of -14, which is -7 squared, which is 49. But instead of adding it on both sides of the equation, since I don't want to change the a, I'm going to add it and subtract it inside the parentheses. That essentially is just adding 0. Now, I don't want this minus 49 inside the parentheses, so I'll keep what I want in the parentheses, which is w squared minus 14w plus 49. And then, using the distributive property, the opposite of -49 is positive 49, so that comes out of the parentheses. Now I can factor, and I get the opposite of w minus 7 squared plus 49, and that's the area. The vertex I can read right from here as 7, 49. Since, like I said before, the graph of this opens down, this vertex will be at where the maximum value is. The maximum value will be 49, where w, or the width, is 7. So we have possible solutions of maximum area of 49, width 7, And the length, as remember, was 14 minus 7, which is also 7. When we get to the check stage, check step, this is a little harder to check. How do you check a maximum? Well, we have a width of 7 centimeters and a length of 7 centimeters. We could graph the equation and see if this is a maximum. We could try some other values, maybe something a little bigger than 7 for the width, which would make length a little smaller. And if we tried several other values, we would see that we would not get an area any bigger than 49 square centimeters. So we move to our fifth step, and that is to state that dimensions of 7 centimeters by 7 centimeters will provide the maximum area.